Look at the screen in your hand. Right now, your eyes are being hit by millions of tiny red, green, and blue dots. Together, they create every sunset, every movie, and every face you see online. But for most of human history, we had no idea how color worked. We thought white light was pure, and colors were stained versions of it. That changed in 1666. A young Isaac Newton, hiding from a plague in a dark room, poked a hole in his shutter and let a sliver of sunlight hit a prism. He didn't just see a rainbow. He realized that white light is actually a chaotic mix of every color. But it would take another 150 years before we realized that we didn't need every color to fool the human eye. We only needed 3. By the early 1800s, a polymath named Thomas Young made a shocking discovery. He realized that the human eye doesn't have sensors for every single shade of the rainbow. Instead, our retinas have 3 types of color-sensing cells, called cones, one for red, one for green, one for blue. This was the birth of the trichromatic theory. Young realized that if you could just stimulate those 3 sensors in different amounts, you could make a human brain see any color in existence. Mix red and green, you see yellow. Mix all 3, you see pure white. This was the cheat code for the future of technology. We didn't need to recreate nature, we just needed to trick the human brain. In 1861, James Clerk Maxwell, the man who mastered electromagnetism, decided to prove this theory. He took a photo of a tartan ribbon 3 times, once through a red filter, once through a green one, and once through a blue one. When he projected those 3 black and white images on top of each other using 3 different colored lights, the world saw its first ever color photograph. It was blurry, it was faint, but it was proof. The RGB model worked. However, there was a massive problem. How do you shrink those 3 giant projectors into something that fits in a living room? It would take a century of vacuum tubes and chemicals to find out. The 1950s brought the golden age of television, but it was a mechanical nightmare. To get RGB into your home, engineers invented the CRT, the cathode ray tube. Imagine 3 guns at the back of your TV. One fires a beam of electrons at red phosphors, one at green, and one at blue. If you looked closely at an old TV with a magnifying glass, you'd see those tiny glowing stripes. This was the first time RGB became a household name. But these TVs were huge, heavy, and dangerous. They used thousands of volts of electricity just to make a tiny picture. Science needed something smaller, something solid. The real RGB revolution happened when we moved from vacuum tubes to semiconductors. First came the red LED in the 60s, then the green. But as we know, without blue, you can't have a full-color display. When the blue LED was finally discovered in the 90s, the floodgates opened. Suddenly, we could build LCD and OLED screens. Instead of giant electron guns, we had millions of microscopic subpixels. In a modern 4K screen, there are over 24 million tiny red, green, and blue lights packed into a space smaller than a postage stamp. We had finally perfected the cheat code Thomas Young dreamed of 200 years ago. Today, RGB is the language of the digital world. It's how we communicate, how we learn, and how we see each other. We've gone from a prism in a dark room to a world glowing with billions of colors. The history of RGB isn't just a history of light, it's a history of how we learned to paint with electricity. The next time you see a vibrant image on your screen, remember, it's just 3 simple colors working together to tell a story. Thanks for watching.